evening, everyone. Welcome you all to the recap session on NPTEL Bioinformatics Algorithms and Applications course. So, in this, I'll try to have a problem-solving sessions on numericals, on the concepts that is discussed in these 12 weeks. Followed by that, initially I'll also provide an introduction to Veka, and also I have prepared some demo files for the practice. So firstly I'll start with Veka. So here I have created a Veka files. So if you see, I have regression files for training, testing and blind, and also have a one simple classification demos file. So if you see, all these files are in CSV formats. So as I discussed yesterday, Veka will accept only CSV format or ARFF format. I'll share this. So one can open the link. The link will take you to a Veka folder. So this folder will have 4 files, 3 related to regression and 1 related to classification itself. So first let me open the classification file. So here I have a lot of columns. First is propensity of helix, hydrophobicity, relative mutability, propensity of beta, odds ratio of tripeptides, odds ratio of mixing, and I have class. Followed by that some external information. Okay, now I can open Veka. This is the Veka Explorer. So in Veka Explorer, we'll be today mainly focusing on pre-process tab, classify tab, and select attributes tab. So first thing, we should load the file. So open file, go to your location where you have kept the files. Change the format to CSV since all our files are in CSV format. So I'll take classification demo. Open. So here in this attributes sub window, we see a list of columns along with that other graphical information. So in this current relation tab, you can see what is the file name. Day 1 demo classification is the file name. Number of attributes. Attributes are nothing but columns, and number of instances. That means number of rows. I think here we can see we have 50 rows here, like 51 rows, one with a header column. So we have 50 rows of data information here. So in this, we don't need some of them. With Uniprot ID, gene name, and mutation doesn't make any sense. So I select these 3 columns and remove them. So now that we have 7 attributes, 7 columns. So here what we are predicting is whether based on these features, whether the given mutation is a disease causing mutation or a neutral mutation. So if we see on class, click on class, you see we have 29 instances for disease and 21 for neutral. So now that we have removed some features, what if in the next step or some other step we feel them they are useful? So one can just click on undo, you get the complete data set back. So but in this analysis we don't need these, so I am removing them. So this is what pre-processing data tab does. So this tab provides several options for data pre-processing, including data filtering, attribute selection and data normalization. Users can apply various filters here. Next is classify tab. So this provides variety of algorithms and options for building and evaluating the machine learning models. So under this classify tab we have classifier. As I mentioned yesterday also, all the machine learning algorithms in Veka are named as classifiers only, whether they are classification models or the regression models. Since we are dealing with an nominal data set, that is it has two data labels, disease and neutral, so mostly the models what we see in this classifier is classification based models. So using this classifier option, choose option under classifier, users can select the classification algorithm from a list of available. So let's see what are the lists that are available. So in this, the machine learning algorithms are grouped into some major classes, that is base, functions, lazy, meta, miscellaneous, rules and trees, which are based on the probability based rules are listed under base, that is naive Bayes related models. Then which are based on some functions, that is logistic function, support vector machine, all those are listed under functions. Then there are lazy algorithms which learn after seeing the new data are listed here, that is k nearest neighbors and other. And we have meta, which are randomized and combined models, and then we have miscellaneous models. So meta means which are highly trained, and like random forest, bagging, trees are all seen here, which are combination of other machine learning models. Then we have rules based methods, and finally we have tree based method, that is random forest, random tree. So one can select any function. So I'll select a simple logistic regression, and under test set we have 4 options. I think one can see, no? Yeah, here 4 options. So first option is use training set, second option is use supply test set, where we have to provide it again. Next option is cross validation, and next option is percentage split. So first let's see what happens when we use training set. So when we use training set, the model gets trained on whole data, that is number of instances we provide. So here we have provided with 50 instances, so the model gets trained on these 15 instances and also tested on these 50 instances. So make sure when you work with Veka, the output column is displayed here. If not, try to change it. But here automatically it recognizes the last column here has the prediction column. So I'll just click start for the model to run on a use training set option. So here we have seen in that output column, classifier output sub window, we see run information and also information about the data set and test mode, what test mode we have selected. So we have selected test mode to evaluate on training. Then also we see different logistic regression rich parameters here. Finally under summary we see correctly classified instances 40, that is 80% of the instances are correctly trained and correctly classified when tested, Incorrectly classified ones are 10, that accounts for 20%. And we have other statistics, that is kappa statistic, mean absolute error, RMSE. So these are all considering based on 0 and 1 as a values, probability based values. And here we see detailed accuracy by class. So under this recall column, first value is sensitivity, second value is specificity, and third value is accuracy. So under this recall column, first value is sensitivity, second value is specificity, and third value is accuracy. Below that, one can observe the confusion matrix as well. One can use this confusion matrix also for getting the classification model related metrics. So these are the statistics that are available for logistic function. What if I change the function? How to change the function again? Go to choose again. Now select SMO. SMO means support vector classifier. I am not changing any test options as of now. I am keeping use training set option only. Then click on start. Now you see the performance metrics has changed. So 88% are correctly classified now, and only 12% are wrongly classified. Whereas in logistic, 80% are correctly classified and 20% are incorrectly classified. So the best model for the data set has to be selected by trial and error process only. And also when we see the metrics, it has a sensitivity of 0.83 approximately, and it has a specificity of 0.95 and accuracy of 0.88, that is 88% accuracy on support vector machine, but 80% accuracy on logistic regression. Similarly, let's see how other, these are under functions. One method I want to select under base as well. I will select basic naive base, start. Now we see different set of metrics again here. 90% of the instances are correctly classified, only 10% are wrongly classified with an accuracy of 0.9. So this is how different functions will perform differently based on the data set that is available. So here when I select base, all the algorithms are available, but when I select functions, some of them are masked. I can't select them, like some of them are masked. The reason because the masked ones are regression based models. Only the ones which are in black are the classification model, and that is suitable for a classification task that you are doing currently. So Veka automatically recognizes the type of the prediction variable, so it is a nominal, so it will suggest us only to select the classification algorithms. So simply I will take one tree based method. I will take random forest and start. So in random forest we have 100% accuracy. All the instances are correctly classified, and also here the chances are that random forest model might be overfitting the model. And now that we know the model is overfitting, so to retrain the model and get a accurate model, generally people perform hyperparameter tuning. So how one should do a hyperparameter tuning is change the parameters of the model. So here you see the name, and it tells left click to edit the properties of this object. So I am just clicking. You see this generic object or editor. So under this one can change the parameters. For example, debug I will make true, number of iterations I will reduce to 10, batch size also I will reduce to 10, and say sorry, you can just click on OK. So automatically they get updated here, and then click on start. See, now the model does not have 100% accuracy, it has only 98% accuracy with 2% of the instances are incorrectly classified. So this is how use training set is used, and
100% accuracy would not be better. Why did we want a lower?
no, here because random forest with the parameters like this back percentage of 100 and all, it's overtraining, it's more the generally it's overfitting the model. You need to check with the test set as well, because what happens is random forest performs very well on training, but when you give a test set or supply test set, the performance won't get good. So because if you see the results here, everything is 111 000 111. So in any machine learning model, accurate classification like 100% results are almost treated as a overfitting of the model, and if this happens on training set, so this is sure the model is overfitting. So to know whether the model is overfitting or not, we should use cross validation or supply test set. Next I'm coming to that. Okay, now that we have selected the random forest model, okay, let me select random forest again. Okay, I've selected random forest, and let's check cross validation. When we have done the training set, results are 100%, but when you are doing cross validation, see, the results got reduced. It's only 82% accuracy and 18% incorrectly classified instances are there. So these are the indications that the model might be overfitted. So when the performance is too good on training and the performance deteriorates very high in cross validation and supply test set, then we consider that particular model has been overfitted. So we try to use parameter, try to change the parameters and rerun the model again.
So how much percent accuracy can be considered good? I mean, to move ahead.
Generally 75%, if a model is performing in 75%, it's a good model, because 3 out of 4 predictions are accurate. But it again depends on what the existing tools are. Like particularly we are working on a stability classifying a mutations, so a lot of tools are there to predict the pathogenicity of a mutation. So like recent tools like alpha missense and other tools have an accuracy of 0.95 as well. That means 95% correct predictions they have. So if you are developing a new method, so we expect our method to perform better than alpha missense, so we should get our method to be more than 0.95. So it depends on what existing methods do. We always benchmark our validation values with the existing methods. If existing methods, none of them is having more than 90% accuracy, 91% accuracy of our method is also good to proceed with. Okay, simply on SMO also we'll try to see how cross validation performs. So the SMO's initial values are 88% accuracy and 12%, and this 12% incorrectly classified. So I use percentage fold 10. This means fold 10 means 10-fold cross validation. If data subsets of 10 are made as a test set, and remaining ones are used as for training. So simply to simplify this cross validation, so first 40 instances are used for training, then remaining 10 are used for testing. This is iteration 1. Then in second iteration, 30 to 40 are used for test set, and remaining 40 are used as training. So this iterations keep on continuing unless all the values once are appeared in the test set. So here I'll click on start. Now you see the percentage has been changed from 88 to 82. So this is how we validate our model. So since 88 and 82 are very close, still the SMO model is very good at performing. So out of 50, 41 are correctly classified and 9 are only incorrectly classified. So this is a second step in generating a machine learning model. So first is training the model, then is validating the model, and also we have test set validation that we'll do when we are learning regression based model. So I have a question here now. So I wanted to do leave or not cross validation. Then what should be my fold number here? So if I want to do 10-fold cross validation, I'm using 10. So leave or not cross validation is the cross validation technique where the iterations keep on continuing, where the training happens on n minus 1 data points and the remaining one data set is used as a testing, and this iterations keep on continuing unless until each data point has once appeared as a test set. So this mentions the number of iterations that we needed. So here number of instances, so we have 50. So if we put 50, then this is leave or not cross validation is what happens here. So now one more option that we have here is percentage split. Supply test set I'll take in regression because I've created a regression test set file there. Percentage split, so here percentage split 80% if I use 80% of the instances are used for training and remaining 10% are used as a test set. Okay, let me do a simple logistic regression only. So under summary, if you see, the data is available only for 10 instances. What happened here is 80% of our data, which is 40 instances, are used for training and remaining 10 values are used for testing. So if you use percentage split values, the validation metrics are only given on the test set. On training set, they won't provide. So this is how a basic classification model is generated using Veka. But still, if users want more options or to see what is happening in each step on each iteration of model development, one can select this more options and they can click output models for training split, and also one can select output of predictors. They can make plain text. Okay, then start. You see, we have input for each instance, like we have 10 data points on test. So first one is actually is neutral but is classified as disease. Second, third are actually diseases and also classified as diseases. Again, third one is neutral and it is correctly classified as neutral. So we can see what data points are correctly classified and what data points are wrongly classified here. So this plus indicates error in prediction. So we have 3 wrongly classified out of 10. So how did I get this is I went to options, under output predictions it will be null by default, so I selected plain text. So the time here is only 0 seconds because only 50 data points. The time may vary up to minutes based on the number of instances we provide. So this is how a classification model is done using Veka. Any points if you want to me repeat, I'll repeat again in classification before I move on to regression. So similar steps we will be doing in regression also, but other things what we missed we will be doing there.
How to decide which model is performing good for my data set?
Yeah, so it's a trial and error. You should keep on try with logistic regression, if not SMO, if not tree based methods. That even in current research here we do trial and error for, so we start with the basic models like MLR or logistic regression, and we keep on increasing the model complexity and see at what level of complexity. So we try to keep our models as simple as possible. So we start with basic models. If doesn't work, we go to level 2 models, level 3, like that. Keep on increasing the complexity at what we achieve our required accuracy or prediction performance. We keep on doing that. It's a trial and error based method.
So a desired result means prediction accuracy should be equal to the training set.
No, it's not like that.
Means sorry, the test set accuracy should be higher or similar to the test set.
I think that scenario will never happen in real world problems. So it's like as close as possible. Mostly, as I mentioned, 75% accuracy on test set, and with a proper sensitivity and specificity measures. We also check area under the curve, F1 score, other metrics also we check. So anything above 80%, like 0.8, is considered as a very good model. But still, again, the question depends on how well the existing models are performing. If the existing models are having a zero point 0.9 accuracy, so to say our model is good, we need more than 0.9 accuracy. It, the class metrics, performance metrics, always depends on what the existing methods do. If there is no existing methods, anywhere around 80% or more than 75%, like 0.75 is a very good model to consider.
No model existing means for my data set, if model is giving not giving beyond 80%, so that I can take forward.
Yeah, see, no model exists means previously no one has worked with your data set. You are the first one to work with that data set or that problem statement. For example, classifying a mutation as disease or neutral. If you are the one who is doing this machine learning model for the first time, then you can proceed with the metrics that you get, like anything around 75%, like 0.75 is a very good model to proceed. But if there are any existing methods, always our method should perform better than the existing methods. Then otherwise there is no need to develop a model if existing methods are performing good. For example, someone in Japan or China developed a model with zero point 0.9 accuracy. So to prove better model, so our model accuracy should be more than that. Either we change the training data or training model, like they might have developed a support vector machine, we can develop a regression random tree, or we may develop a nearest neighbor method, so that we keep on changing so that our method performs better than the current existing research methods.
Okay.
Okay, let me clear. So this is about the classification. In regression also, I have given three files here. One is train file, test file, and blind. So I'll explain about blind set later on. Now I'll start with the train and test. So first I load the train data, because first we need model to train. So I just select train and I've loaded. So here we have contact order, number of CO contacts, O contacts, P factor, H bonds, this docking based delta G values. This is electrostatic energy. We have number of this hydrogen acceptors, number of rotatable bonds, and finally what we are predicting is log IC50 value is what we are predicting. So this is a real value prediction problem. Inhibition concentration we are predicting. So if you see here and try to select the models, see, previously we have used SMO and logistic, they are masked now because they are only specific for classification problem. So Weka automatically recognizes what type of algorithms are suitable for the given data set and it suggests to us. So here let me select basic linear regression, and I just initially wanted to see how training set data performs here. So here I have correlation coefficient of 0.9 and mean absolute error of 0.37, RMSD of nearly 0.5, like that, and we have instances for each prediction. So in the first instance, that is first row of a data set, the actual value is 1.88, but the model predicted as 2.119. So the error is nearly 0.2. Like that we can see for all the 50 instances. So similarly, one can see the validation using a data set. Let me use tenfold validation. So the performance metrics change, and here you see data for each fold here. So the our data set is split into 10 subsets. So 50 data points without any overlap. If we split into 10 data sets, each data set will have 5 points at random. So you can see, so where the numberings are 1 to 5, 1 to 5, 1 to 5, 1 to 5, like this. So this is how a 10-fold split happens. So if I make a 5-fold split here, you can see here 1 to 10, 1 to 10, 1 to 10, like that. So this is how cross validation splits are done. If I leave one not cross validation, so at a time only one data point is considered as test set. So 50 iterations are done, so 50 test points. So here we'll supply external test set. So external test set also should have same columns like train file. So here you see number of attributes as 6. Close.
Test set can have any number of rows. Matlab, it's not necessary कि 80:20 ratio should be there. It can have 50:50 also. I mean, if like in this example data set 50 training sets are there, so 50 also in my test file, it will also be okay, right?
Yeah, you can go with any number of test data points. There is no limitation, but one tells that more number of training instances, more better is the model, but there is no limit on number of data points that to be used as a test set. Generally, if there are any existing data sets that are used as a train or test set in previous study, and you find any new data set which you can add into it, so these new data points are mostly added into a training and tested on the similar old test set. So training means the model performance will automatically, if it see a new data, it trains on a new data and performs well. So this is what general trend what people do.
Okay.
So here, okay, I'll try to do. So here, when our test set is not matching with the train set, it tells train and test are not compatible. Would you like to automatically wrap the classifier? You can do, but still this is not suggested. Let's see what are the columns our test file has. So demo test file, one second, has O, B factor, H bond, ADT, and number of hydrogen acceptors. So our training set should also have only these has columns. So remaining ones I'll remove. So OO, CO I can remove. Then electrostatic energy I'll remove. Remaining ones I will remove. Now that I have same. this is what performance metrics what we see on our test data points of 7 points. I have 7, like one heading column and 7 instance columns. So this is how external test set is supplied to evaluate the model performance. Previously, when someone can see the model has a correlation coefficient of 0.8, but when we tested on it, here it has an improved correlation performance. But as if we keep on changing the models, this is support vector regression again. So first let me start with the test set. So it has 88%, it has a correlation of 0.88 and mean absolute error of 0.37 approximately. Then I'll use supply test set option and I'll open the file, test set, open, close and start. Now one can see the error has increased from 0.3 to point. So always we don't get exact performance metrics on training and test set, but mostly we try to keep that errors as low as possible. Coming to regression based models, we try to always maintain our mean absolute error less than 1 or anywhere close to 1 if at all possible, and correlation coefficient as possible as close to 1 value. So the model which has mean absolute error of less than 1 and a correlation value near to 1 is termed as a very good model in regression terms. So similarly, one can change different models and do trial and error model to get the best training model. So one that I forgot is, how did my supplied test set only have less features when I compared with my training set? Okay, just let me undo this. So we have the select attributes tab. So here one can select any methods. So here what they tell is that out of the given inputs, they tells what are the best features that are required for our model. So here we have attribute evaluator and search method. So one can select based different options, like these are for regression model and automatically, so generally people go for this C subs of evolve or correlation attribute evolve. So I'm just keeping C subset evolve, and search method is I'm selecting the best first. So whatever the best model combination that I see, feature that I see at first, I take it out. So if I click start, you can see these are the features what we have made it in the test set. O, like oxygen contacts, B factors, H bond, Autodoc tools, delta G energy and number of hydrogen bond acceptors. So these are the best features that give best performance on our model. So further, the model building should be performed using these best selected attributes and should be tested based on these attributes only. This is how you reduce the dimensionality of your system. So initially we have 7 features, now we have reduced to 5 features. So it's a lot of time that one can save instead of evaluating on non-informational features. So this way one can reduce their time by reducing the number of features. So this is Veka. So any more clarifications needed, I'll provide. So one more I left out is the blind test set only. Why did I prepare the blind test set? In blind test set, if you observe, in the last 2 rows I have kept as a question mark, remaining I kept some as a test. So what Veka does is, when a Veka encounters this question mark, it predicts its value. Instead of evaluating, it just predicts its value. Let's see how it does. So this is on whole data set. So I have whole data set loaded, then I go to classify. In the supplied test set only, I give blind data set, open, close, then I click on start. When you see here in the 51 and 52, For question mark, two values has been for first question mark the value is minus 0.383. For second question mark the value is 1.892. So this is how predictions on new data were made using VECA. So instead of giving output value, prediction value, give a question mark. VECA will get trained on the data, training set data, and supply your blind test data as test, and it will make predictions here.
So these predictions are from the training data set that we supplied.
Yeah, based on training data set. Yeah, if I change anything in the training data set, the value will change here again, because training happens in different way and the value will change again. So this VECA, the hands-on training on VECA for biological and healthcare applications, we do as a workshop for 2 days, where the course instructor Professor Michael Cromie also takes a part, and we as a TAs give hands-on training along with the project-based certificates. So it's a certificate-based workshop. But I think recently we have done one. If there are any future, I'll also post it.
So these are online workshops or in person?
This is a completely online workshop in collaboration with NPTEL. You will like the participant, like whoever has attendance criteria, they'll get a participation certificate, and whoever performs well in the projects, like we have also some projects to do based on VECA. Like similarly, what we have done. Similarly, we give some question and answer based. So if anyone like based on the scores, we also give completion. Two types of certificates one will receive from NPTEL only.
What is the cost of the workshop?
Uh,
Somewhere around tentative.
like last time for PhD scholars, we had around 800 to 1000, I think so. I'm not sure. Like it's around that range.
So if one has to attend, so we should contact through NPTEL.
No, like we'll keep on posting that. Actually, at regular intervals, we keep on doing. Like recently, we have done one in somewhere around Feb, I think so. So since you are part of this course, next time when we do, automatically we'll send you a notification through all the course students this time.
Okay, so through mail we'll receive the notification.
Yeah, whenever we are doing notification, like 1 month advance or at least 1.5 month advance, we'll send a notification. It won't be a sudden. Or still any doubts regarding this VECA using, also you can contact me personally. It's not about that workshop also. Like we are available to train on this model developments anytime. Like you can contact us through mail.
Okay, thank you. So contacted means directly to you or through NPTEL or through Professor Gromiha.
No, if uh, that's what. If it is regarding the course, this bioinformatics NPTEL course, kindly use that Q&A and contact us through NPTEL. If not, you can contact us personally. It's no issues. You can just mail us
Okay.
directly what is your problem, sir.
Okay, thank you. You are in which year of PhD?
I'm in my 4th year of PhD.
Okay.
So you are student, faculty.
Me, I completed my postdoc.
Okay. So you are currently faculty.
Not faculty. I just recently completed my postdoc, so I'm looking for another opportunity.
Okay. So this is what about VECA I have. So here I have prepared some practice questions that we have done throughout. So here given reading frames, we know mRNA is divided into reading frames. So each strand has 3 reading frames. To 2 strands we have totally 6 reading frames. So given, for example, DNA sequence ATG, TCG, GAA, TA, the possible 3 reading frames would be, so reference how 3 reading frames are considered. So my example shows for mRNA, but still the difference between DNA and mRNA is only T in DNA is replaced with U in RNA. So the first frame starts at the first nucleotide and splitting them in a pairs of 3. So first ATG is one codon, TCG is second codon, GAA is third, and TA is the fourth one. Next, frame 2 will start at the second nucleotide. So remove A, so TGT, CGG, AAT, and remaining is TA. So this is an incomplete codon. The frame 3 starts at the third nucleotide. So remove AT, so GTC, GAA, ATT, and A. Again last we have incomplete codons. So this is how these codons are further converted into amino acids based on the codon table. So here I have two questions. How many 2-letter words can be formed with the letters ABCD allowing repeats? So this is just a practice for next question. So how many 2-letter words can be formed with the letters ABCD allowing repeats? So each position in a 2-letter word can be filled by 4 options, and each letter filling is independent from each other. So 4 into 4 is 16. So 16 2-letter words can be formed with the letters ABCD allowing repeats. Similarly, how many 3-digit number can be formed from the digits 1, 2, 3 allowing repeats again? So we have 3 positions now. So 3 positions, 3 independent ways of filling it. So 3 into 3 into 3, it's 27. So how many codons code for a stop codon in genetic codon?
3.
It's 3. So if A content in a DNA sequence is 14%, what is the percentage of GC in the same DNA sequence?
Yeah. 72.
Yeah, so if A content is 14, T is also 14, so AT content is 28, so GC content is 100 minus AT content, that is 72%. So the average hydrogen bond energy for the sequence AT, TA, AT, AGC is given individual values are.
minus 8.75.
Yeah. So here we have sequence AT AGC. So we consider overlapping dinucleotide peptides. So the first pair is AT, second pair is TA, third is, and next is GC. So their corresponding values are minus 7, minus 7, minus 9, minus 12. So sum of these values is around 35. So the average is 35 divided by number of pairs. So we have 4 pairs. So it is minus 8.75. So number of overlapping trinucleotide obtains for a DNA sequence of length 20 nucleotides is so in previous
18.
yes. So in previous question we have 5 nucleotide sequence and we have got 4 overlapping dinucleotides. So sorry. Similarly, number of dinucleotide are given as n minus 2. So where n is length of the DNA sequence. So 20 minus 2 is 18. Di means n minus 1. So which amino acids are charged and considered basic?
B.
So it is lysine and arginine histidine based on their side chains. So what is the significance of identifying locations of insertions or deletions in sequence alignment? So whether they are determining for financial correlations or unveiling the structural similarities, assessing language syntax, or inferring relations since a common ancestor divergence. So these insertions and deletions, if we identify, we can infer relationships from a common ancestor's divergence. So here I have two types of situations of hemoglobin. One is normal hemoglobin and other is sickle cell hemoglobin. So which type of hemoglobin is apparently more polar and soluble in water, and which type of hemoglobin is more non-polar and insoluble in water? The only difference between normal hemoglobin and sickle cell hemoglobin is glutamic acid at position is changed to valine. So this makes it a sickle cell hemoglobin from normal hemoglobin. So out of these two, so which is polar and more soluble in water, and which is hemoglobin is So based on this, we see the first 5 are same. The sixth amino acid is here is glutamic acid, so which is charged amino acid. So this contributes to the polar nature and solubility of the protein. And here what we see is the charged amino acid is replaced by hydrophobic. It's mutated to a hydrophobic amino acid valine. So this makes it more nonpolar and insoluble. So here I have given an alignment. The match score of the alignment is 3, and the mismatch score is -1, and gap is -1. What is the net score of this alignment?
B 5.
Okay. So here this is the alignment. So the first condition is match, second is mismatch, again we have match, here we have gap, mismatch, gap and match. So the match score is 3, mismatch -1, match 3 again. The gap is also, sorry, the gap is -1, mismatch is -1, gap -1 and match is 3. So overall you have 9 minus 4, which is 5. So the answer here is 5. So similarly I have one more. So here now I have changed the alignment as well as the match score and mismatch score. Try to calculate the net score of this alignment. Here the match score is 4 and the mismatch score is -1 and gap is -2. So this is the alignment. So first condition is again is match. We have gap, match, gap, mismatch and match. So here the match score is 4, gap is -2, match score is 4, gap -2, mismatch -1 plus 4. So here we have 12 minus 5, that is 7. So this is a question related to global alignment. So global alignment is mostly performed using Needleman-Wunsch algorithm. It is aligning one complete two sequences from one end to the other end. So here I have constructed a partial matrix. So I have completed the matrix initialization step, that is filling the first column with 0 0. Then also aligning the matrix towards the gap, that is in the first row and the first column we subtract with the gap penalty. So here based on this, what is the question mark value? So question mark is here. So it corresponds to T in one column and D in other column. So what is this value? So the condition for this cell is it's a mismatch. So in one sequence we have A, another sequence we have T. So this is a mismatch condition. So this is the matrix. So along the diagonal we see whether it's a match or mismatch. So it's a mismatch, and along this we add gap penalties. So we should take maximum of 11 minus mismatch score minus 5. So it is maximum of minus 16. 14 minus 14 minus gap penalty. I think gap penalty is minus 2. Sorry, minus 3. So it's minus 17, and 0 minus gap penalty minus 3. So the maximum value out of these 3 is minus 3. So the value that corresponds to the question mark is minus 3. So here it is minus 3, and it is obtained from 0 cell, the cell having the value 0. So here I have a local alignment. The local alignment is different from global alignment because in global alignment we have 3 conditions, that is match or mismatch, or gap penalty from horizontal column, or gap penalty from vertical column. But here we have one more column, 0, that is maximum of 0, match or mismatch from diagonal, and gap penalty from vertical and horizontal columns. So let's try to find the value of a question mark using this local alignment provided here. So here again the condition is mismatch. So let me move on here. So this is how. So since this is a mismatch, we have a minus 5 here. So again I have gap of minus 3 and gap of minus 3. So we need to check maximum of 7, 0, 0. So this 0 is from here, this 0, and maximum 4 condition. So here the final value of this cell is 7. So we have a basic question here: in what alignment two sequences to be aligned are assumed to be generally similar over entire length, and in what alignment, on other hand, does not assume that two sequences in question does not have similarity over the entire length. So in global alignment, we take two sequences to be aligned are generally similar over the length, and in local alignment we see for local similarities, not the global similarities. So I have this basic 5 basic BLAST programs. So you have a protein sequence and you used to know what other proteins look like. So what type of BLAST to use?
Plus two.
Yeah, BLAST P. So next you have a DNA sequence and you wish to search for other DNA sequence to find that one encodes the same or similar protein.
T plus 10.
No, we have DNA sequence. Our query is DNA sequence, and we are also looking for a DNA sequence that is similar to a protein. It's T blast X. No, we have DNA and we are looking for a other DNA sequence to find that encodes the same or similar protein. So it's a T blast X. In T blast N we have protein, and that checks for DNA. So we have DNA, and you wish to find other DNA sequence that look like is so it is nucleotide blast or blast N. Then if you have protein sequence and search a database against the finds a database to find genes that encode a similar protein is T blast N here. So here I have question related to number of rooted trees. Number of rooted trees. So for given 3 nodes, number of rooted trees that are possible are. I have given a formula here for reference, but in exam no formulas will be given. We expect one to memorize these formulas. So here the exclamation mark tells factorial. So factorial of 1 means 1. Factorial of 2 is equals to 1 into 2. Factorial of 3 is 1 into 2 into 3. Factorial of 4 means 1 into 2 into 3 into 4. So we have number of nodes as 3. So 2 into 3. So we use rooted tree formula minus 3 factorial divided by 2 power 3 minus 2 into 3 minus 2 factorial. So this is the formula we use. Then now we have 6 minus 3 factorial divided by 2 power 1 into 1 factorial, that is 3 factorial into 2 into 1 factorial. Which is equals to 3 into 2 into 1 divided by 2 into 1. 2. So number of rooted trees we have is 3. So similarly one can calculate how many unrooted trees are possible. So here the formula for number of unrooted trees is 2n minus 5 factorial divided by 2n to the power of n minus 3 into n minus 3 factorial. So 0 factorial is also considered as 1. So when you apply this formula, you will get answer as 1. So here I want to calculate the molecular weight of a peptide given individual amino acids molecular weight. So try to calculate the molecular weight of the peptide lead seq. So here I have added individual molecular weight. For leucine it is 125, for glutamic acid it is 145, for alanine it is 85, for aspartic acid it is 130, for serine it is 100, for again glutamic acid we have 145, and we have glutamine 140. And here I have added some extra term. This is because when a peptide bond is formed between two amino acids, the water molecule has been released. So that is a condensation reaction we see there. So minus number of peptide bonds that are possible. So here we see one peptide bond. Sorry, we see one peptide bond here between E and A and D, T and S, S and D, E and Q. So totally 6 peptide bonds are formed. So 6 peptide bonds means 6 water molecules are released. So this is how the calculations are done. Then this is just summing up the subtraction related formula only. So it is nearly 870 minus 108, I think. So it is 762 is the answer. So as I mentioned, peptide bond formation, a water molecule has been released. So it is 762 is the answer. Then I have given one more simple NPTEL, smaller protein. Try to calculate for it. So this is like a practice. This you calculate.
553.
Yeah, yes, it is 553. Yeah. Yeah, the answer is 553. How we have got to that calculation is individual molecular weights, and here we have 4 peptide bonds forming. So 4 water molecules weight has been removed. So the sum of these is around 625. Minus 18 into 4. So this gives 553. So here I have one, how many rooted and unrooted phylogenetic trees are possible with 6 different sequences. So this is quite a bigger number to calculate, it will take time. So take it as a practice. So here I am giving the result. So if we take 4 species, we have 15 rooted trees and 3 unrooted trees. And if we take 5 species, we have 105 rooted trees and 15 unrooted trees that are possible. And if we take 6, we have 945 rooted trees and 105 unrooted trees. So here I have given a sequence, identify a sequence for the given pattern here. So I'll try to explain little about the pattern here, where the X denotes at that particular position any amino acid is possible. The square brackets ALT tells at that particular position of square bracket alanine, leucine or threonine is possible. This curly braces means any amino acid except the ones that are inserted into those curly braces, and how the repetition is defined. So the repetition is defined in this round brackets. So if the number 3 means 3 types of 3 next to 3 places XXS, so that is any amino acid is possible. So based on this information, try to identify a pattern which try to identify a sequence which matches the pattern.
D.
So in the first position, any amino acid can from any amino acid from PLA should come. So all the options agrees with that. In second place, X, so that any amino acid should come there. So if we take option 1, it's given as X. There is no amino acid with the name X. So option A has been eliminated. Then in third position, it's G. So now option C has been eliminated because in third position we have P. So only now the answer should be one among B and D. So in the next position, it shouldn't be, in next two positions it shouldn't be K or P. It should be anyone. So if we take, that is in position 4 and 5, it shouldn't be K and P. So if we take in option B, the position 4 itself is K. So then if we see here, the position is R and A, and last is Y. So option answer is D. I think I didn't put, but the answer is D here. So here I have some basic questions before we wrap up. The solvent accessibilities of residues: alanine 7, glutamic acid 8, valine 9, asparagine 10, and alanine 11 in a protein are 0.2, 56, 1.2, 1, and 78. So of these, which are the residues that are located on the surface?
Valine 9 and asparagine 10. Option C.
Option C. Okay.
D.
Why it is option C?
D.
Okay. So generally solvent accessibilities. So the residues that are located at the surface have higher value of solvent accessibilities. So if you see here, we have only two higher values, that is 56 and 75. So 56 is 8th residue, 78 is 11th, so it is B. So remaining are having very less, like 0.2, 1.21 Armstrong square solvent accessibilities. So these are buried residues. The ones with the higher values of 56 and 78 are the surface residues, that are surface exposed residues. So the accessibility of residue arginine 74 in folded state are 78 and 165. So the percentage of accessibility is, it is just a basic division. So accessibility in folded state divided by accessibility in unfolded state, and since I asked in percentage, convert that division value to percentage. So yeah, even there was a question yesterday, so when to give it in a decimal points and when to give it in a percentage. So since the answer here asks for a percentage value, so we expect you to give in terms of percentage. If there is no this percentage symbol, then we expect you to give in decimal points.
To convert it to the percentage, what should
45.43.
be the denominator?
No, first you calculate the decimal, and if it is asked in percentage, just multiply the decimal value into uh, multiply the decimal
100.
value by 100. So similar I'll show here. So we have here 78 divided by 65, so which gives around a recurrent value of 0.7472727 like that. So now we have a decimal value, but since the answer is asked in percentage, just multiply this by 100, so it is 47.2727 like that. So just we can stop it for two decimals. So accessibility in folded state divided by accessibility in extended state, and into 100 is the percentage of solvent accessibility.
Sir, how 48, 78?
Sorry?
How 78 came, sir?
No, yeah, these solvent accessibility values has been calculated using a rolling probe experiment we call. So when you take a protein structure, a probe has been rolled, like probe has been rolled across the surface of a protein. So this probe generally we take for globular proteins as water. Like you expect on a protein solid surface, we are moving a circular object of radius 1.4 Armstrong. So the area that is uh, what you call the area that has been covered by this center of this rolling probe is termed as this accessible. This 78 and 165 are calculated. Like on a
Okay.
surface, we are just rolling a circular probe of a particular radius, and the area driven by the center of the probe is generally considered as the accessible area. Or if we go for membrane proteins, water is not used as a probe. Any lipid related substance of probe size 2 is used. So there is a particular concept called rolling probe experiment, like which is computationally done. It's not an experiment means which we do in the lab. It's a computational experiment. The name is rolling probe experiment.
Got it, sir.
So I have contact order related. So a protein has 50 residues and through 200 contact. Residue alanine 45 has contacts with residue 46, 47, 44, 71 and 60. So what is the contact order of that residue? So try to calculate first S of I, that is sequence separation between residues I and J. So here separation. So the sequence separation between residue 45 and 46 is 1, 45 and 47 is 2, 45 and 44 is 1, 45 and 71 is 26, and 60 and 15 is 1. Then sum of these sequence separations divided by, that is the formula is S of ij divided by L into N. So the sum of these. we have 45 divided by 200 into 50. Which will be approximately 0.0045. So the value here is, so similarly one can calculate long range order. Long range order is further simplified. So instead of using direct distances here we have a binary classification. If the sequence separation between them is greater than 12, then we take the numerator value as 1, if not 0. And we have only divided by n, that is total number of residues in the protein. So if we move on to this, here only in two cases we have sequence separation more than 12. So it is 2 divided by 50. So it is 0.04. So because it's already 1.5 hours, and take this as a last question before. So these questions are important in terms of exam, so I wanted to solve this in the last session. So use the data given below to answer the questions. The IC50 values of two protein ligand complexes are given, and IC50 values are related with hydrogen bond donors and polar surface area. So try to find the regression coefficient of hydrogen bond donor and regression coefficient of polar surface area given the IC50 value of a compound. And finally also try to find the IC50 value of a compound with 3 hydrogen bond donors and a polar surface area of 3. So first let's consider hydrogen bond donor and polar surface area. So hydrogen bond donor as x and polar surface area as y. So then generate the equations and try to solve these equations to get the answer. So solve it and do let me know. I'll also try to solve. Okay, so given these two equations, so I have considered one as equation 1 and equation 2. So just to simplify the equations, I have multiplied equation 1 with 3 and equation 2 with 4. So these are results. Then I subtracted them. So I have got y value as minus 3. So then I'll use this y value in any one of the equation, that is 6 equals to 3x plus 4y. So the equation is 6 equals to 3x plus 4y. So 3x equals to 6 minus 4y. So that is 6 minus of, sorry, yeah. So 6 plus 12, it is 18, and x equals to 18 divided by 3, it is 6. So x equals to 6 and y equals to minus 3. So given in the question, they asked us to find the IC50 value of a compound with 3 hydrogen bonds, that is 3 into 6 minus, okay, took off the minus there, 3 into 3. So it is 18 minus 9, that is 9. So the IC50 value of a compound is here 9. So 6, 3 and 9. So I given some of the practice questions also. Do go through them and upload them. Mostly by tonight or tomorrow early morning I'll be uploading in that problem solving session portal. So that's all from this session, and this is the last class for this 2025. So thank you all for attending. If any other questions, I'll take those in any other concepts as well. If no other questions, thank you. Some of you are very regular in those classes. Thank you for joining those classes, and all the best for your exams.
Thank you, sir.
Thank you.